Good morning, Math Analysis. So today I'm going to be teaching section 4.2, which is called Critical Paths. And our job is to find the earliest start time for each individual task. And then once again, yesterday we talked about which path is the critical path. We'll redefine that today. So the critical path is actually the longest path from start to finish. And believe it or not, it is, let me get that written down from you, from start to finish. The critical path is going to be the biggest number out of all of the paths, because remember, you cannot finish the entire project until the slowest person figures their portion of the work. EST, that stands for earliest start time. So the EST, or the earliest start times, are referring to what is the soonest that any individual job can get completed in. So it is the earliest time it takes before we can start that job. Okay, when we calculate earliest start times, we put parentheses under the letters, and we put our number inside of there, and everything gets measured with respect from time 0. Everything measured with respect to time 0. Okay, so we're going to try one of these. So let's take a look at this digraph right here. So the first thing I'm going to do is I'm going to go through and I'm going to put some little parentheses under each of the tasks, because below each of those tasks I'm going to write the earliest start time. So here we go. So I'm going to go along here, and when I look at A and I see how long did it take to start, it didn't take any time at all. So I'm going to put a 0 down. So we can start A immediately. So then I'm going to continue on, and I'm going to go from A to B. And so the number that goes underneath B is I add how long A took and the amount of time it took to get ready to do A. So 0 plus 1 is 1. So the earliest time for me to start job B is 1. Now, depending on which way we go, we're going to have to go both ways. But if I go this way, so I'm looking for C now. The earliest start time for C is, well, it takes 1 to do B, and it takes 1, let's call them days, before I could begin B. So I add those two numbers together, and the earliest start time is 2. So all I'm doing is adding the number to the left of the letter, and then the number underneath the task that was the previous task to this one. So if we look at E, there's only one arrow going into E, and so I know that it takes 1 day to complete job B, and 1 day before we could actually do job B. So the earliest start time for E is also 2. Now this only gets tricky when there's more than one arrow going into a letter. So it's still pretty easy here. It takes 2 days to get ready to do job C and 3 days to actually do job C. So the earliest time we could start job D is in 5 days. Okay, let's look at job F. Now in job F, I'm going to use a different color highlighter here to point out to you that there's actually 2 arrows going into job F. And the thing you have to recall is that with earliest start times, you cannot start the next job until the slowest guy has finished. So if I'm at D, it took 5 days to get ready to do job D, and then job D takes 2 days long. So if I added those two, that would be 7. Versus it takes 2 days to get ready to do job E and 1 day to actually do job E. So the earliest start time for that would be 3. So I'm deciding, do I put a 7 here or do I put a 3 here? Well, you always go with the larger of the two numbers, because you cannot start job F until the slower people finish their job. And so we have to wait for job D to be completed. Okay, let's look at G. You'll notice there's also 2 arrows coming into G. So I'm going to select the earliest start time, and once again it's kind of an oxymoron. The earliest start time is actually the biggest number. So D, it takes 5 days to get ready to do it, and it takes 2 days to do the job. That's 7. Or we have 2 days to get ready to do E and 1 day to do E is 3, so I'm going to go with 7 because that's the bigger of the two numbers. Okay, you'll notice that H also has 2 arrows coming into it, so I have to decide, am I going to go with 7 plus 2, which is 9, or 7 plus 5, which is 12? So the earliest time that I could start H is 12. You always go with the longer of the two because you have to wait for the slowest guy to finish his job. And then there's only one way to get to the end. Job H takes 3 days. It took 12 days to get ready to do job H. So when I'm done, that answer is 15. So now what I have to do is I have to go and tell myself which path was it that was 15 long. So there's actually 2 ways you can do this. The more time-consuming way is to list each and every path individually and look for which path was 15. It would be your largest path. The other way is you can work backwards. So I'll explain right now how you work backwards, but if that doesn't make sense to you, then just list all the paths. So if I'm at 15, 15 minus 3 is 12. So I'm just going to kind of look backwards from here. So I know from finish, the job that I did right before that was H. Now from H, I either went to F or I went backwards to G. So I'm just going to undo my math. So is 12 minus 2 7? Nope, so it wasn't F. 12 minus 5 is 7. So I must have gone this way then. So the job before that was G. Now from G, I was either at D beforehand or E beforehand. So do the math. 7 minus 1 is not 2, but 7 minus 2 is 5. So that means that I must have been at D just previous to this job. And now there's no choice. We can only go from D to C. And from C, we can only go to B. And then from B to A. So this path that I just worked backwards by undoing the math I did is what is known as the critical path. It is the earliest time that the entire job can be finished. And there you have section 4.2. So we will go on to the second half of the sheet right here if you want to learn a little more. Okay, now it's your turn. I would like you to take a look at this diagram, and I would like you to list all the possible paths that we can take from start to finish. Go ahead and do that right now. All right, so take a look and see how you did. Did you get these 4 paths? So if I asked you right now what the critical path was, what would you say? Hopefully you said that this last path right here was the critical path because it is the biggest of all the paths. That is the earliest we could finish the job in 15 days. Okay, so now they're going to start to ask us to do a couple things. So the first thing they're going to say is, what happens to the critical path if F changes from 2 days to 10 days? Find the lengths of all paths from start to finish and put them in Q1 above. So you could go back to your diagram and you could change F on your diagram, or you could just look at what you have written here. So the first thing I notice is that in my first path, F is not a part of it, so that is not going to change how long it takes to get done. In my second path, F is a part of it, and if it goes from 2 to 10 days, that means it's going to add another 8 days to what was already taking 12 days. So that would be 20 days. In my black path, yes, F is a part of that, so I would also need to add 8 more days to 8, and 8 plus 8 is 16. And in the last path, there is no job of F, so we have 15 here. So the question is, did the critical path change? And yes, it did. You'll notice that now our third path increased from being 8 to being 16 now, which is, oh, mistake by Miss Gagliano. Ho, ho, ho. Sorry. Okay, so that is not my critical path. Take a look. The 20 is my critical path because that is the largest number. So my new critical path is A, B, C, D, F, H. I'll write that one down. Okay, when we go back to the next problem, we're going to assume we're going back to the original times. So ignore what I put basically in this first column right now. So let's look at the next example. What happens to the critical path if G is changed from 5 days to 3 days? So that means that anybody that has G in it, we're going to reduce the time by 2 days. This one up here, anybody that had F in it, we increased the time by 8 days. So they want us to go through and do that. So let's take a look at just our original times. And this first one, yes, it has G in it, and so I'm going to decrease 11 by 2, and that gives me 9 days. The second path does not have G in it, so it will stay at its original 12 days. The third path does not have G in it, so it will stay at its original 8 days. And the last path does have G in it, so I can lessen the 15 by 2, which is 13. So when I look for my new critical path, I find that A, B, C, D, G, H is the new critical path, because A, B, C, D, G, H, that is the earliest we could complete the whole project, which is actually the longest path. Okay, so now we're going to look at problem 3. This one requires a little bit more creativity. Problem 3 says, change one task time to create 2 critical paths. Find the lengths of all paths from start to finish and put them in column 3 above. So change one task time to create 2 critical paths. So once again, we're looking at our original job here. And currently, the critical path is, remember, the biggest number. It's this guy right here. So one way to do this is to take a look and say, who's another path that has a letter in it that is not in the current critical path? So I notice when I look at the second path, it does not have a G in it, but it has an F in it. So if we could change F's time in the second job, so let's see, F currently is at 2 days. If we changed F and make it be 5 days, then you would notice that would add 3 more days to that path. So that would make this path be 15. Be sure you check all your other paths though. It won't change this time because there is no F in there, so it's still the original 11. This one, remember, we added we added 3 to that, so that would change that to an 11. And then finally on the last one, F was not a part of that, so it was 15. So now I have a tie for the critical pass, and I did that by remembering F started at 2, and basically I added 3 to it, and I changed it so F now went to 5. There is one other option. You could try and do it and take a look. If you had changed G to 2, that also would have worked. Okay, the last one is a nice challenge. You should try that one and see how you can do. So pause the video and see if you can figure it out. I will put the answers down here right now. And if you would have changed E to 5 and changed F to 5, you would have ended up with, believe it or not, 4 paths that are all the same length, which means that all 4 of them would be considered the critical path. So this is section 4.2. Your quiz will be over these 2 sections on Tuesday. You'll have review on Monday, and there will be video lessons that you can watch. Thanks. Have a great day.